Hello, everybody. Welcome to our RAG Hack live streams.
RAG Hack is a free global hackathon happening from September 3rd to 16th. RAG is a technique to get a large language model to answer questions based off your data. We have more than 25 live streams teaching you how to build RAG apps with different Microsoft technologies, plus 10 cash prizes for the best RAG apps in each category. So we're super excited to have you join us for this RAG Hack. And now a word from our friends at Reactor.
Hi, everyone. Thanks for joining us for the next session of our RAG Hack. Pick the right model for the right job. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. And while we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer. Our session is being recorded. It will be available to view on demand on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenter. Thanks for joining us today.
You are on, Facundo.
Awesome. Thank you for the quick intro. Hi everyone. My name is Facundo Santiago. I'm a product manager in Azure AI, and I work particularly in all of our inference technologies and on how our developer experiences look like in the product. So today I'm gonna be with you talking about how to use how to approach this model availability boom that we see out there, right? So we have not 100, but probably more than 50 options, right? Like when you're talking about using large language models or any of those foundational models in your application, and then you can start wondering, okay, which one should I use, right? For each of the scenarios, or which is the best choice that I can use for all the models, so I can maximize the value that they have. So we're gonna be talking about here how you can approach this problem, which are the models that you have available, particularly in Azure AI, and how you can switch. You can start with one approach, and then you can change your approach, and you're optimizing the work you're doing in order to make better choices on the models you're picking from the things that you had available. Through the presentation, I'm going to be showing a couple slides just to present some ideas, but then we're going to be switching to code. First, I'm going to show you a Jupyter notebooks just to explain some concepts, so we don't get lost in a particular application. And then I'm going to show you an application that is actually using the technique that we're seeing under the hood. So with that, let's get started. So this picking the right model for the right job. Sorry, I should have moved to this slide after. But so what's the agenda? I want to see even how this model availability is changing right now, how to approach the model selection. I'm going to show you a bit of the model catalog, how to switch models, and then how to approach an evaluation about how to make a decision about what you're doing. Cool. So basically, this is kind of a screenshot that I took from the from LMSys arena. So LMSys is a web page that tracks how different models compare across each other across different tasks, right? So it's just like a battlefield across models, right? It's probably, I think, 1 month old, so probably there is some new content here in this screenshot. But basically, something that you can see very quickly is that, of course, there are very popular models like GPT-4o or Claude 3.5 that are really good at most of the tasks, right? But then as you start seeing specific models across each other, then there may be one model that is really good at one particular task versus some other models that may be very good at other particular task, right? So we see here the average of the model, right? Models are really good at most of the task, right? But then when you double click on the score that is one of each models, then you can see some sweet spots about maybe a particular model is very good at something in particular, right? So how should we approach this, right? Like how can you select, like when new models coming in each and every month, like how you can approach this problem? And this is also even more important when you take into account SLMs, right? Like small language models, which are really pushing the price of the performance for getting a large language model to solve a particular task, right? So now for simple tasks that maybe in the past you used to use a code approach, right? Like a more, let's say, deterministic approach where you code something particular, maybe you can just offload that particular task to a small language model, which is good enough to solve that particular task, and it's not that expensive for make you think twice, right, about using it for it. So how can you approach this, right, in the real world? And the thing is that the model that you choose like actually matters, right, like in real life. So how can you can get started working on this? And the first question that you should ask is like, so can AI actually solve the problem that I have at hand, right? And in this phase, what you're trying to do is actually prototyping, right? You're trying to understand if the problem that you have at hand can be solved actually with a model. And at this moment, you want to use the best model that you have available at hand. And the reason for that is because, like, if the best model that you have available at hand cannot solve the problem, maybe you should not even think about going further with the project, and you should either rethink about your problem definition, approach it in a different way, or maybe continue with the approach that you're having right now. All right. So at this moment, as I said, like you want to use the best model that you have at hand. Then once you validated that, then the next question they're probably asking is, okay, what's the best model actually that I can use, right? Like, is the best model that I have available actually the one that is best at this particular task, right? And in this phase, what you're trying to do is trying to optimize, right? You're trying to attempt multiple techniques, doing probably some prompt engineering, trying to find out if a particular modeling approach, like doing RAG or doing a very particular assistant or agentic pattern makes sense. You may also be starting to consider if fine-tuning is something that you want to consider in this roadmap. Probably it's not the first thing that you're considering in this phase, but probably later, once you have tried out multiple approaches, maybe you may start considering fine-tuning as a better approach, right? So basically here we're trying to do is optimize the workload that you have and trying to find out which is the best model with the best strategy that you can use to actually solve the problem. Of course, in some scenarios, you may find out that maybe you need to rescope the project that you're working on. Maybe you need to redefine the solution that you're doing, and you get back to the prototyping phase, and then come back here once you redefine that. And then finally, that you have something that is optimized, that you think it's solving the problem at the best of the capability that you have. Then you're trying to wonder, okay, like what does it look like when I deploy to a real world, right? Like, so once I need to scale this to maybe my entire organization, maybe to my to all the users that I have, like they're trying to get outside of like an MVP V1. So probably you're now wondering about how you can optimize things, right? Like, so at this stage, you're trying to wonder, okay, some capacity, some cost trade-off, maybe that the solution, be monitoring what the model is doing, and trying to be more cost efficient about what you're actually doing. And this pattern that I just showed there is very relevant, like when you take into account like all the models that you have available in the industry, particularly in Azure AI. What we have done is trying to make a selection of all the models that you can find out there and try to put it in front of you to choose, right? So to enter to that process I described. And when you go to our Azure AI model catalog, you will see a very large selection of models from flagship providers like OpenAI, Mistral, Cohere, and also various particular offerings, like, for instance, our Phi-3 model family. And you also can find really niche large language models. Like, for instance, we have some forecasting models that are really good at that particular task of forecasting, computer vision models, and whatnot, right? So basically the objective of the model catalogs is basically bring to you the innovation in the AI space, no matter where it's coming from, right? Like, we want to put that in front of you so you can actually go through that process that I just described before, right? And when we do that, something just to keep in mind, we do this like with all the principles that we have in Azure, because, like, now in Azure AI, you can be consuming models from Cohere, you can be consuming models from OpenAI, you can be consuming models from Meta. But since you are running in Azure, you have all the guarantees in terms of data privacy, compliance, and responsible AI of our cloud. So, for instance, data is not shared with any of those model providers. So any of the data that you send to our service is never shared with them, neither for training, neither for monitoring. There is no a single piece of data that is going to them. And also, when we receive those models and we deploy them on Azure, they also go through a very detailed analysis to make sure that they don't have, for instance, model vulnerabilities inside of them. We even scan the weights of the models, because, like, there are some specific attacks that can be placed inside of the model weights in themselves. So we took care of that. And even, like, when you are deploying this, you have all the enterprise features that we usually have in Azure, like private networking, intra-ID, and industry certifications, right? And finally, like, each time that you get access to a model in Azure, we'll put some content safety systems in front of them, so you can actually consume these models in a responsible way. So just like to keep in mind. Okay, now this is great that we have a lot of models available in Azure. It's great that we can, right, like, you can pick and choose, or you can find which is the best one that you can use. So how can you actually start to prototype, experiment with different models, right? And something that you need in order to do that, in order to experiment with different models and try to see how each of them go, you need to have a way to change the prototype code that you're working on, the MVP beta version V1 of your model, how you can change it to now target different models, and so we can start experimenting. And this is something that we had taken very seriously on Azure, and this is like the reason why we have introduced something that we call a common inference schema, right? And we call this schema the Azure AI Model Inference API, and it's basically it's a contract that we put in all the models that we offer, where we guarantee that the same contract is going to be used regardless of the model that you're using, right? So you don't need to learn specifically how the API for Llama 3.1 405 billion parameters works, right? Like, it's the same one that it works for Mistral Large, and it's going to be the same one that it works for Cohere Command R, right? Because, like, when we put these models on Azure, we put this common schema on top of all of them, so you can use the same code to consume all these models. And what I have here is just a demonstration of how this actually works. So we have here 3 models, 3 notebooks side by side. One is connected with Cohere Command R+, the other one is connected with Mistral Large, and the other one with Phi-3. And what we're using here is the Azure AI Inference SDK, which is an SDK that can be used to consume any of the models that we have on Azure, basically. And we're making the same question to each of the models and see how they respond. Nothing complex here. It's just a chat completion question, and you see that it's exactly the same code in each of these notebooks. So nothing has been changed besides the endpoint that is hosting each of these models, right? Of course, like, something that you saw probably towards the end of the of this screen is that the answers that you get from each of these models is different, right? Like, so a model maybe can more explainable, like it tends to have more explanations about what is going on. You may see other models that have a tendency to make references to the answers that you're doing, and some other models that may be tempted to do more concrete, short answers towards the question that you're doing, right? So at that moment, like, you start seeing kind of the attributes that the model provider has choose in order to build the model that they are building, right? And this is kind of like when you start like thinking about which is the best model that you can use. So you need to do less, right? Like less prompt engineering, less like on constraining in terms of token or explaining everything that you need, because you're relying a bit more on how the model has been trained particularly, right? I will see a couple of examples about this. So in order to show you like a concrete example, so let's build something very particular, I will show you how we can start using multiple models, like to construct a RAG application to solve a particular problem. And then we want to see how you can actually inspect what is going under the hood, so you can see what is going on and understand how you can make improvements. So in this example, I'm gonna build a RAG system, nothing new, that is gonna answer questions about Paul Graham, right? And basically the work that he's done in particular. And for that, we wanna have like a data source that have multiple documents about this, right? We have this on a data store that is gonna function as an index for this. So to keep this simple, when I store this on memory, so we're gonna be working with AI search or any vector index, so we keep focus on the models, not on the vector retrieval part. So keep in mind that we have that a bit more simplified here. But the complexity we're gonna add is like when I put a router in front of our RAG system, so we can make better decisions in terms of the question that it's gonna ask and the strategy we're gonna use to answer it. And basically, we're going to provide two different approaches to answer the question that the user may have. For those questions that are, let's say, simple, so it's a simple, more concrete question, when I use a vector index retrieval to do that. So basically, what this is going to be doing is it's going to, let me put this, it's going to retrieve some regular documents from the index and try to generate an answer using a large language model, right? But if the question is a bit more complicated, when we try to use is a summary tree query engine. And this engine, you're going to see that in a minute, but it's going to do something a bit more sophisticated. It's going to retrieve multiple documents, not only one. It's going to try to summarize all the ideas that is on each of these documents. And then we're going to try to generate an answer, a more comprehensive answer based on all of those retrievals, right? As you can see here, the approach at the top is quite much, of course, it's simpler, but it's also less expensive, right? Because you have less calls to an LLM to resolve it. While the second one is more complex, right? It requires more calls to large language models, but also you have more chances to bring all the relevant content that you need in order to provide a more comprehensive answer to the question that you're making, right? So let's see how we can actually implement this in using, in this case, I want to be using Llamaindex to implement this. Can everyone see this this notebook that I'm showing here?
Can you make it larger? It's actually a bit small.
Okay.
Larger is always better when we're streaming.
Definitely.
We do, by the way, have a question maybe for later about pricing. I don't know if you already talked about that in your thing, but if you can talk about that at some point, definitely interested in how the pricing works for these models, if it's per token or model size or whatever.
No, that's a good question. I think is relevant here. So when we say like, probably you hear me here on the talk saying like, hey, like we have more complex models that are really good at a lot of tasks, and then you may have a specific models that are really good at a particular task. So sometimes that's related with the complexity of the models at the size of the models. So bigger models, more complex models tend to be more expensive, and simpler models or more narrow scoped models tend to be cheaper because the size of the model is smaller, right? So how the price is defined? Because I'm telling you these trivial things like large or small, and how can you know like if the model is large or small? So usually this, in some cases, like the weights of the model or the complexity of the model is disclosed to you. Like for instance, when you consume Meta Llama 3, like you have multiple sizes, so you have an idea of the model of size. But then you may be considering, I don't know, GPT-4o or like Mistral large, and you don't know exactly how many parameters are behind them, right? So when we expose you a price, in all the cases, the price is per token, right? So this is super interesting because like you have the same, let's say, purchase unit regardless of the model you're choosing. So you're being billed in the same way, regardless if you're using GPT-4o, Mistral large, or Phi 3, right? Like in all those cases, all different model providers, but you're gonna be charged by token. Now the difference is the price of each of the tokens. And usually the price is directly related with the size of the model that we are consuming, right? So larger models tend to have a higher price per token, and then smaller models tend to have a smaller price based on the token. But in all the cases, you're billed per usage, which is really interesting in this demo that we're doing here, because it costs nothing to us to switch a model, right? Because like when you point to a different model, you're just paying a different cost per token. It's not that you have a fixed cost, or, oh no, if I want to consider using Mistral large, I need to pay upfront something, or right? Like it's nothing like that. You always pay by usage.
Great, thank you.
Awesome. So we have here a notebook, and this is big enough. Oh, I can do one more, I think. Appearance. So let's close this. Don't need it right now. Okay. So in this note, I'm going to show you a bit like how we can build like the RAG retrieval application that I described on the slide. So basically, what I'm going to be doing is like I have a couple of models deployed in Azure AI, and then I configure these endpoints inside our embeddable variables, right? So actually, if we go to my Azure AI Studio, you will see here in the section deployments, where all the models that I've been using are being listed. And I have like a lot of models available, right? I have models from OpenAI, GPT-4 3.5, 4. I have models from Cohere. I have models from Llama. So it's like different models that I have deployed here. Again, like all of these models are being built per token. So if I don't use it, I don't have to pay anything. Right, but they are available to me to use them. And I have all that configuration loaded and embeddable variables, so I can use them in a much simpler way. So something I'm going to be using is I'm going to be showing you what's going under the hood in some of these scenarios. So for that, I'm going to be using an instrumentation solution, so I can be logging what is going under the hood when I'm using a particular framework. In this scenario, I'm going to be using Llamaindex to build our RAG system. So because of that, I'm using a Llamaindex instrumentator, right? And you can use whatever the tool that you feel comfortable, like for tracing, right? Tracing is going to tell us like exactly what's going under the hood. So in this case, I'm using prompt flow tracing, which is available to run locally in my computer, or I can use it connected to AI Studio. Right. In this case, I'm gonna be using locally, so you don't have to worry about like connecting with AI Studio or like seeing in the cloud. But you have both of the options, right? And what I'm doing here is starting the tracing. So all the code that I execute here is gonna be monitored, but the tracer and any call that I make to a large language model is gonna be catch and register, so I can see what is going under the hood. I really recommend like to have an instrumentor if you're using any of these SDKs for building AI applications, because it can get really tricky sometimes to know what is going under the hood, right? So you may be using something, it may be like Llamaindex, maybe LangChain, semantic kernel. You may be wondering like what how specific things work under the hood, or which tasks are being used in a large language model and which ones are not. So it's really interesting to have a tracer at hand to know exactly what's going on, so this doesn't look like magic to you. So to configure the instrumenter is very simple. You just instantiate the Llamaindex instrumenter, and then you call instrument. Right? So from this point on, all the code that you execute is going to get instrumented. So in this particular scenario, so to show you a complete example, I'm going to be configuring Llamaindex to work with 2 particular models, right, for our RAG system. For generation, right, I'm going to be using a large language model from Cohere Common R+. And for embeddings, I'm going to be using also an embedding model from Cohere, which is Cohere Embed V3, right? How I can consume model from AI Studio from Llamaindex is we have an integration package in Llamaindex, and you can instantiate this classes Azure AI completion model for a large language model and Azure AI embeddings model for an embedding model, right? The interesting about this is that these classes are the same regardless of the model you're consuming, right? So if at any point you decide to change it, actually you're going to be doing that. You can actually just change the URL of the model that you're using, and then you're good to go. So the next thing we're going to be doing is here I'm configuring Llamaindex to use the models that I just mentioned above. This is fairly new in one of the last versions of Llamaindex. You can configure the entire session to use a particular large language models using this class setting. So it's really nice to set it at the top. So then all the code that you use afterwards, it will use these models that you just configured here, right? If you are familiar with older versions of Llamaindex, we used to have something that is called the service context, which they recommend just stop using and now move to this one. And here what I'm going to be doing is loading our data set, right? As I said, for this simple task, I have all my documents in local storage, so nothing complex here. I'm going to be loading these documents into memory. I'm going to be parsing them and getting chunks of text, and then I'm going to add these documents to a doc storage, right, which is also local and is also in my memory. So I don't need any vector index or anything. So we can simplify our work regarding to that. Now let's go to kind of the more concrete part of this, right? What I try to be doing is implement the query engine that I just described before, right? That is going to try to select which is the most interesting strategy based on the complexity of the question that the user is doing. And for that, we're going to be constructing 2 query engines first. The tree summarizer and a vector index query engine, right? Query engine are these elements, if you're not familiar with Llamaindex, is the construct that is used to implement basically a retrieval step and a generation step, right? That's basically a query engine. So for the tree summary, remember that this particular engine, remember that it retrieves multiple documents and generate a summary of them, and then tries to generate an answer based on what was found in multiple documents, right? So to instantiate this, what I'm going to be doing is generating a summary index. I'm going to be passing the nodes that I have and the storage context that I built. Remember that the storage content that I have is in memory, so nothing fancy there, but you can change that for something different like your vector database. And that's going to be constructing from that summary index. I'm going to be constructing a query engine, right? And you can achieve this as simple as using the AskQuery engine parameter. And then I'm saying that the response mode is a tree summarize, right? So tree summarize, remember, is grabbing multiple documents, generating a summary, and then generating the answer, right? And I'm using asynchronous query in this scenario, using asynchronous calling in all the code that I'm using. And the second one is the vector store. The vector store, remember, this is a simple query engine, nothing fancy here, and also generating the query engine for this particular vector index. So once I have a vector query index for each of these strategies, then I'm going to build like kind of like the top level query engine that can select which one to use depending on that, right? And for that, I'm gonna be defining the concept that Llamaindex calls a query engine tool, right? And the interesting about the tool is that you can give like the strategy that the tool is gonna be using, right? For instance, the summary tool, basically is describing the query engine that is going to be using, the summarized query engine. And if you see here, I give in a description about in which scenarios this should be used. Here is saying that it's useful for summarization questions related to Paul Graham essay on what I work on. Right? When I see that Llamaindex is going to use this description to decide which strategy they need to use. And then I have here the vector tool, right? Which is exactly the same thing. I just construct a query engine tool. I pass which is the engine that I need to use, and then a description about when to use this one. It's like it's useful for a specific context from Paul Graham essay on what I work on. Once I have the tools, what I'll be using is a routing strategy. So the system can decide in which scenario they need to use. And here, if you see, I'm using an LLM single selector, right? And I pass in the two options or query tools that can be used to answer the user question, right? I mean, if you inspect this a bit closer, you see that the selector is called LLM's single selector, right? So this is giving you a hint that under the hood, this may be using a large language model, right, to make the decision. I'm going to see that in a minute, how it works. So for that, we can see how this works. Like you can make a question to the system and then see what's the answer. Instead of showing this here, I think it may be a bit more interesting to show you in an app. So I have here, here it is. So I have a Chainlit application. Wait, oh, I'm not in the right folder. I don't know if you have ever used Chainlit, but Chainlit is a UX, really interesting to build applications, or at least to test different workflows for applications and get a UX to interface with them. So if you see like LangChain application, the Chainlit application is running now, and actually see that. I'll show you like this code so you can get a closer look. The objective here is not to learn about Chainlit, but it's really interesting because you can just interact with the application directly here, right? So I'm gonna make a question to this system. I'm gonna send it here. So if you see, the system has come up with an answer, right? And actually I can see some of the reference documents that were used to answer this question, right? This is where like having tracing is very interesting, right? Because like here we saw that the answer came back, but how can we know exactly what's going under the hood, right? And for that one, I have here prompt flow tracing running locally. So if you see, you have here a local instance running here, and this is the local, let's say, tracing version of all the things that are going on by Llamaindex. And I see that all the things are going here. But basically, what I see as one of the things that was executed is like the base query engine has been executed, right? So this is basically the question I just put. And we can see here all the steps that Llamaindex has executed, right? Like you see, there's a lot of things that were going under the hood to actually answer that particular question, right? And we see here the question, right? Like what did Paul Graham did after Rix? Something that we can see very quickly is that we see that the first thing that was executed is like there is a router query engine, right? You remember that we created this, and then an LLM single selector was called. And if you see when this code was reached, an LLM predict, was executed, and actually an Azure AI completion model complete was called. So here we can see clearly that a large language model can be used to solve this particular problem. And here we can see that the model that had answered this is a Cohere Common R+. And we can see actually what's the prompt that that Llamaindex is given to the system, right? So you see that here the prompt says, like, some choices are given below. It is provided a numerical list, 1 to 2, where each of the 8 items in the list corresponds to a summary of the tool, right? And here you see like the 2 options, right? Option number 1 is useful for summarization questions related to Paul Graham essay, and option number 2, I'm going to highlight it here, is useful. Sorry, I need to zoom in, to retrieve a specific context from, and it continues, right? So you see here that the prompt that Llamaindex is actually using to make the decision, right? And actually, we can also see what's the answer that the large language model has come up with. So it's saying that it's selecting the choice number 2. And the reason is also giving us the reason why it chose that one. We may use this to validate that actually it makes sense. But basically, we see that it's selecting the choice number 2, that if you remember, choice number 2 is like to retrieve a specific content, right? So it's using the vector index approach, right? So once that is solved, it's saying like use the vector index approach. Then if you see, there is a vector index retriever, right? Retrieving some relevant documents. And then you have the final generation step on a RAG system, right? You see that again, like a base synthesizer is being used, and then basically a model is called. And in this case, again, the model that is answering this question is Cohere Common R+. And we see here the prompt also is giving all the context information that was retrieved on the index, and that is asking, hey, can you generate an answer to the user question based on that, right? So it's really interesting, right, like to have these kind of tools at hand, because you can see exactly what is going on under the hood and make decisions based on what you're seeing here. Let's go back to the notebook. So all the code that you saw there is just on an app. It's easier to expand it there. And if I use the other, like for instance, like what did Paul Graham do after X, which is, sorry, this one is the one I just executed. If I come up with this one, let's do it. So you can see that is more complicated question. Something I'm going to start seeing is that it takes more time because it's making further requests to the large language model here. And also needs a final step to generate an answer based on all the documents that it was retrieving, right? So you can already start seeing that this is a more expensive approach, not only on money, but also on time for the user experience, right? So you really want to use this strategy when you are sure that the question that you're asking is complex enough. Okay, let's see. When it comes back, it is expected to take long because I think I use a very large number for the amount of documents. But time on TV is always a tyrant. Let's see if it is running, just in case. Yeah, we can see here all the requests that it's making. So it's still making requests. We see the request ID changing. And you can see also the URL that is being hit. This is because I'm running the application with tracing on.
while we're waiting for it to come back, we did get a question: is
Okay.
how do you restrict the user from asking complex questions?
Oh, that's okay. Just come back as you see, like it's getting back with a lot of text, and if you see, okay, like this is why like it took so long. Look at like how all the documents that it retrieves and it generates summaries from. So like, okay, clearly it make a complicated query. You actually don't have a way to restrict the user to from asking complicated questions, right? But if you know that you have this kind of systems, right, like when you may take different approaches based on the complexity of the query, this is actually what I'm using here is like part of a family of techniques, which is usually called like rewriting query techniques, right? Like when the user asks something and then you change something that you're doing under the hood based on what the user said, right? This approach that I show you here is one of them, but some other that you can use is that you never pass the question that the user asked directly to your system. You just never do that. And what you do instead is you ask, again, another large language model to rewrite that question in a way that is better for you to execute it. Right? For instance, one technique maybe like you just ask a large language model, hey, the user asked this question, rewrite the query in a way that I can provide factual, that I can retrieve documents in a factual way, or like taking into consideration specific aspects, right? That is short, that is like whatever. So you can ask a large language model to actually change that, so you can take a meta decision based on that. That's usually a technique.
Yeah, that makes sense. You could also set, like timeouts and limits on, stuff like how many things are retrieved and how long a particular step could take to just prevent, because now we have the potential of getting DDoSed by our users, right? So to, you want like a hard cap on how many resources they can actually use and how long their request could take.
Yeah, definitely. The only thing when you have a long task and you want to time it out is that you're already investing some time and also some money, right? Because like the query is going on. So how you can take a decision, should I abort it and just throw away all the work that I did, or should I just wait a bit longer? Yeah, definitely it's tricky. Yeah. Okay, cool. So something that we saw is like there is a lot of language models going under the hood, right? Like, so some of the tasks that you're doing, like they're calling multiple language models. So this is like the first thing that you can do to optimize things, right? You can start like experimenting. Okay, there was one large language model was used to when we saw the trace, we had the first call to the large language model that was actually just selecting a strategy, right? And that's a simple task. If you compare that to, hey, generate an answer, right here at the bottom, generate an answer of this question based on this document. Like you're asking the model to reason a lot more, right? So when you identify this kind of scenarios, then you can start doing more cost optimization, right? And trying to pick a better choice or a simpler model to actually answer the first task, right? Because like selecting which strategy, that's a task that like probably a small language model can do perfectly without any problem, right? And also having the same performance. So something that you can do is like since remember that we're using this Azure AI completion model, and I told you you can just point to any model that supports our common API to use it. Then this is as simple as just instantiate a new model. In this case, we are instantiating a Phi3 mini model, which is a really small model. It's one of the smallest model inside of the small language model family of Phi3. So from the family is kind of the smaller, and just use it directly. But in this scenario, you want to use this one just for the router. You want to keep the Cohere Common R+, which is a very complex model, for the generation because you're asking more there. But for the selection, you want to use a different one. And this is like very interesting about Llamaindex. You always will see this parameter, LLM equals to something. By default, is none. That means that it's using the global configuration that you have in your setting. But you can tell the system, for this particular task, use this particular model, right? So that's the only thing I'm changing. I'm putting like LLM equals to SLM, right? And that's all you need to do. So I actually have that on the app that I show you, like more like configurable way. So I can go here to the settings section here at the bottom, and I can change the URL of the router LLM that I'm using. So I'm gonna go back to my AI Studio. I'm gonna grab that Phi3 mini. That was the one that I used. Did my session maybe timeout? Okay, there it is. I'm gonna copy the URL of this one. I have to rotate the keys after this. And confirm. And if you see, what it's saying is that now my router is using this endpoint that I'm showing here. And if I ask the same question, I using the query here, the answer came back again. But if I go to my tracer now, I want to see what is going on. So we'll see again the new query that I just created. But if I see the first step, now is being answered for a Phi3 mini, right? And you see that the same choice was made by the model, right? Just it choose choice number 2. But that's the only step that was executed using that model, because if you see the Azure completion task, still is using the Cohere Common R+, right? So this is kind of like a technique that you can start using to understand, okay, where you can make implementation or optimization in your workflow, and then decide if you want to use a different model and for that particular task, and instead of using the general configuration, right, for that particular model. However, a valid question is like, okay, we saw only one example here, and it output the same thing, nothing changed. Is it safe to change the router for doing this? And usually you're going to be doing for that is building an evaluation data set to actually measure if this is actually the right approach, or is actually damaging your performance in a particular way, right? And for building an evaluation data set, you have multiple approaches. You can just generate your own data set manually based on queries that the users are giving to your system. Or another approach, that the one that I'm using here, is actually to generate a data set for evaluation based on your data, right? And you can use any large enough, I would say, model to build an evaluation data set. It's not a complicated task, but you want like a model that is very good at explaining things and relating ideas. So in this case, for instance, I'm using a Mistral large model to generate the evaluation data set. And Mistral large, the reason I'm using it is because it's a model that is really optimized for RAG. It has really this tendency to make references to things, right? But there are multiple models that work in this scenario. And you just generate an evaluation data set that will generate like pairs of questions, answers based on your data that you can use to evaluate your system, right? And when you're building an evaluation system for this, let me go back to my my slides. You really have to have into consideration these 4 things. I'm gonna go like super quickly about this, but there is a relationship between the question, the context, the answer, and the ground truth, right? So the relationship that exists between the question and the context is usually what we'll call the retrieval score, right? So it's trying to measure, I retrieve some documents, how much relevant is the context that I got into the question that the user asked. Then you have the relationship that exists between the context and the answer. And we call this the groundedness or the faithfulness. And this is basically the answer that I generated, how well is grounded into the context that I gave. If you are familiar with this is usually what we call the hallucination, right? So if you have an answer that is not related with the context, then you say that the model is hallucinating. Then you have the relationship between the answer and the question, right? And this relationship is called relevance. You really want answers that are related with your question that the user asked, right? This is directly related with the experience of your user. So this is probably one of the ones that you care more. And the other one that is very tricky is the relationship between the answer and the ground truth. Right? You generate an answer. How true is this answer? And we have multiple approaches here. GPT similarity is one. F1 score is another thing. What I'm trying to tell you is that you need a way to measure this. And the metric that you choose is picking one relationship between these four things. And we don't have the metric that measure everything today, at least, right? So if you're measuring only one thing, you're probably doing it like you are like falling short. You really need to be measuring a couple of things at least. You don't have to measure everything, but at least like measure the things that are more important to you. And Llamaindex has a way to generate those retrieval scores. It has a faithful evaluator that measures the faithfulness of your system and the relevancy of your system. And remember that when you are evaluating a model, you are also usually using the technique that is called LLM as a judge. Basically, you're asking another model to judge the output of another model. And in this scenario, you usually want to use the most powerful model that you have at hand, because this is actually deciding the quality of your system. In this case, I'm using GPT-4 for judging the outputs, right? And it's as simple, like in the same way that we did with the router, I can tell Llamaindex, hey, like let's use an evaluator with this particular model. I want to use GPT-4 as a judge. And then you can just run the evaluator on your generated data set and try to calculate what's the outputs. I think I should have the outputs here. Here's right, and we see this is the faithfulness score and the relevance scores of the system. I don't have it here, but I ran the same evaluation also on the system with the optimization, right? Like with changing router, and there was like just a small. Sorry, I didn't put it here. Just a small drop in the relevance scores, which can perfectly be just for randomness, right? So you're getting exactly the same relevance, the same faithfulness score at a cheaper price, right? So this is the kind of optimizations that you want to do when you're trying to look which is the best model to solve a particular task. You try to change the model in that scenario, and then you run your evaluation so you know in which scenarios you are making an improvement and in which scenarios you're not, right? Because like changing models like blindly, or at least without taking into account how they are affecting the entire system, is usually a risky task. And I think with that, I reach the end of the, let me see, I think I reached the end of the presentation. Yeah. So if you're interested in this example, I have all the code, including the chainlit application that I show you on the UX. So it's more interesting to interact with it. And also the notebook that we show here. So you can take a look about how you can switch models in this scenario, how they affect.
All right, thank you, Facundo. So we have a couple more minutes, and there are a few questions.
Mm-hmm.
So one thing is, you just showed the evaluations, and I'll actually be talking about evaluations using the same SDK in just a couple hours. But how do you, when you do the evaluations, how do you decide which score is good, and whether you've seen an improvement?
Mm-hmm. Yeah, I mean, if we go to that slide, I think like for me, this is like I actually have this on my notes because I think it's so visual and so interesting to know this relationship. You typically, if you see, you are interested on all the things all together, right? Like there is nothing that you say like, no, I don't care about this, right? Like usually this goes directly to the quality of the system that you're building. So I wouldn't say that you have to rule out one metric or another, right? But definitely all these metrics will give you different things, right? Some of them are more like straightforward, right? Like for instance, retrieval count score is something that is more simpler to calculate or to, or more, let's say, easy to rely on, because it's more simpler to see if a question and the context are related to. It's a simple task. Again, like always think about this with a large language model in mind, resolving the task, right? Because this is using LLM as a judge. So an LLM is being called to generate this score. So relating the question with the context is simple. It's simpler. I won't say this simple, but it's simpler compared to analyzing the relationship between an answer and the best possible answer, right? How that is really tricky, right? Like, how can you tell if an answer compared to another one is better? Of course, like, you may check for factual things. That's simpler. But if someone is more convoluted, the other one is more straightforward, which one is the one you want? And how you measure that? So that one is much more tricky. And for instance, in that one, is really interesting to start having humans in the loop, actually people taking a look and scoring when they are good and when they are not good. But like you need to really think about what's that complexity on the task. Of course, like, you can have someone that it really really direct. So if you're making a system where the faithfulness, or like that the system doesn't hallucinate, is paramount for you, you really want a system that doesn't hallucinate. You'd rather have invalid answers, like saying like, hey, I cannot reply to this, rather than to have an answer that actually says the wrong things. So probably groundfulness is something that you put at the top, right? But I think that's how you approach this. Like, you need to see what's the problem that you have and what's the best strategy, or what are the metrics that are more related with your business goal.
Yeah, I agree. I use groundedness more than I use similarity. I don't even use similarity anymore because
it's really tricky, that one, and yeah, it's not that reliable today.
Yeah, I get. So that actually, and that I now have a question: is can you set the seed parameter with these models in the model catalog? Because seed is something we usually set. You know, when I'm using the OpenAI models, do we have seed for all the Azure AI catalog models too?
That's a great question. Not all the models support seed, unfortunately. The parameter is in our SDKs, in our API. In the case that you attempt to set the seed, the model is going to reply with an error saying, like, hey, I don't support seed. In the cases that they don't, right? Like, we have models that support it, like GPT, for instance, supported. I think one of the versions of Mistral also supports seed, but the rest may not support it. Something that you want to do is, like, we have a parameter in our API that is called, like, hey, if there is a parameter that you don't support, just silently ignore it. And that's really interesting to set seed, because seed is kind of a best practice. You really want to set seed if the model supports it, right? And if not, you just play with the other parameters, right? Like, still you need to set the temperature to 0, at top P to 1, right? Like, if you want more probabilistic, let's say, or less probabilistic answers. So what the API can do is, like, if the seed is supported, it's going to use it. It's not, it's just going to execute.
Okay. Yeah, that makes sense. All right, cool. So we are at time now. Thank you so much, Facundo, for the great slides and the notebook and answering the questions. It's really cool to see how you can use all the different models and swap them out too.
So thank you for the invitation, and yeah, let's if you have any feedback, you can reach me out on social network. Like, you have the code available, so if you see anything, just open a conversation on GitHub. I'm super active there.
Awesome. All right, thank you.
Thank you.
Hey everyone, hope you enjoyed today's session.
If you aren't registered yet for RagHack, you can register now at aka.ms/raghack/register, and you can introduce yourself on our forum. You can start hacking either by looking at one of our code samples or just starting from scratch. If you have any questions along the way, feel free to post them in our GitHub discussion forum, and you can also attend live office hours in our Discord. Once your project is ready, Make sure to submit it before September 16th at 11:59 p.m. PT to be eligible for our cash prizes. And of course, make sure to join our upcoming live streams to learn more about RAG. Thanks for joining.
Thanks, everyone, for joining. Thanks to our speaker and Pamela. To learn more about our series, watch past episodes, and register for future sessions, you can follow the link at the bottom of the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can also find that link on the screen or in the chat. We'll see you for the next one.